Hi everyone, today is the second day of exponents, square roots, and order of operation and scientific notation. And example number one is just finding the area of an object that is required. Now in this case, is the orange area or the shaded area. I will tell you is this area. And to do that, finding all the other little tiny areas, but assuming this picture is as one whole. And to do that, we are going to split up into different little parts. There's a whole bunch of rectangles. Area of rectangle is length times the width, and then we are going to separate them up into different parts of rectangle because they are different shapes. So I'm going to call the smallest one is first type, the second type right here. But if you notice there's three of them of the same thing, take that into consideration. So now what we're going to do is we are going to say, all right, look at the numbers on the side, 0.06, and you have the 2 on each bars on the bottom. To find the area of number 1 right here, you are going to do length times width, which is, I'm going to write it out, area number 1, that's going to be the length times the width, which is 0.06 times 2, and that will be area of number 1. And then you can tell that's going to be 0.12. Then the area of number 2, if you look at it, is going to be on the side 0.9 times 2, 0.09 times 2. But also recognize I have 3 of them, so I'm going to times 3, and that answer will be 0.54. And because we are asking the whole thing is to be 1, to find the orange shaded area, take the 1 whole minus the area in type 1, 0.12, minus the area of type 2, 0.54, and 0.34 is going to be your orange shaded area or the red shaded area. Example number 2, translating from English mathematics. We have done few of this. Please pause the video and try example number 2 yourself. Answer for example number 2. I do like to read through it with you guys one more time. Remember, I like to read my things backwards. And if you read your things backwards, you can say 7 times a number. Well, 7 times a number is pretty easy. That's just 7n. Then 5 more than 7 times. 5 more means plus. So 5 plus 7n will be answer A. Then the B, 6 times the difference of a number and 9. If you're just looking at a number and 9 and not looking a little bit further back, you're going to get confused and put a plus sign. I have a number n and 9. What am I going to do with it? Difference of a number and 9. That's why I got my difference. Then it's 6 times the difference. So 6 times the difference. So that's what you need to be careful on. What is the operation between the two numbers? Then the next one, letter C, you have 14. Well, I put down 14. Twice the number subtract. Twice the number subtracted from 14. That's 14 minus 2n. On example number 3, let x be a number. Translate the phrase 6 minus the product of negative 5 and the number into a mathematical expression just like the things above. Then evaluate means plug it in, the expression for x equals negative 3. So pause the video, try this yourself. If you read backwards, the product of negative 5 and a number. So here's what you do, because remember, something and something you want to double check, is it really a plus sign? There's operation talking about product of that group, negative 5 and a number. So that's a product of a negative 5 and a number. 6 minus, so 6 minus that product. It's going to be negative, negative become positive. And then they want you to evaluate expression x equals negative 3, and you just plug it in, and then you get equals negative 12, because positive 5 and negative 3 gives you negative 18. So that's example number 3. For example, the number of cases worldwide unruly passenger behavior on board aircraft was 2.7 thousand cases in 2009, and it increased by 1.4 thousand cases per year for the period of 2009 through 2014. The source is from the International Air Transportation Association. So A is asking, let T be the number of years since 2019. Okay, that's where T starts. For example, T equals 2. Okay, T equals 2 is stand for, since we started 2009. 2 years after that is going to be 2009 plus 2, and that's going to be giving me 2011. So that's for 2011. And then let's read on. Because 2011 is 2 years after 2009. Use a table to help find an expression that stands for the number in thousands of cases of unruly aircraft passengers behavior. That's a typo. The year that is since 2009. So we want you to do things in thousands. So please do not write down the number because that's too much writing. So here's the table we want to do, and 0, 1, 2, 3, and then, all right, 0 is year 2009, and then 2010 is going to be 1, 2, 3, and I'm going to use a T just to set up the table. So the first one is going to be started off is 2.7 thousand in 2009. And every year after that, it's going to be 1.4 increasing. So the first one, it didn't increase, it's just the number itself. So plus 1.4, we didn't do anything. But starting from that year on, it increased by 1.4. After the first year, you are going to have plus 1.4 times year 1. You're going to 2.7 plus 1.4 times year 2. 2.7 plus 1.4 times year 3. Now, if you notice the number just keep on changing on the years, that is where we're going to put in the variable. Variable is the number constantly changing. So 2.7 plus 1.4, since I don't know how many years, I'm going to put down T because T represents all the years that can possible come by. So now that is the table. Then what you're going to have is letter B says, evaluate the expression you find in problem 1 for T equals 5. What does your result remain in this situation? And because it keep on changing, you should know where to plug in the number. So please pause the video. So for example number 5, we have the problem solving percentage problem. And when you're solving percentage problem, the attendance at the Broadway is going to be 12.3 times 0.29. That's going to be 0.3567 million people. And then when you subtract 12.3 minus 0.3567, that leaves you with 11.9. 11.9 million people attend the Broadway show in 2010. Scientific notation. And scientific notation says that a number is written in scientific notation if it has the form n times 10 to k power, where k is an integer and absolute value of n is between 1 and 10 or equal to 1, but definitely does not equal to 10. Example 6, write the following numbers in scientific notation. One thing you have to understand, scientific notation's decimal is at the end, and then depends on which way you're moving. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The reason for that I'm picking 4.01 is because it has to be including 1 but less than 10. So 4.01 is the possibility times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 10 to the 11th power, because the number is a big number, and if you think about it, the decimal is right here. So how do we get to a big number? You got to multiply something big, and that's positive. Go ahead, try letter B. You have the decimal at the very end, and you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it should be 10 to the 14th power. On to the next one, because again, we are making a number bigger, but it's positive exponents. Then here we are making things smaller, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You guys go ahead, try letter D, because the number is smaller, so it's negative exponent. Smaller number, because it's a decimal, negative number. Example 7, write the number in standard decimal form. That means take it out of the scientific notation, because this is positive right here. So we are going to make sure that the number gets bigger. So it's going to be 3.52 gets bigger number by 10 to the 4th, 1, 2, 3, 4. So fill in the 0, your answer should be 5,200. Next one, you have the negatives. So you have 7 times negative 3. That means making the number smaller by 3 decimal places. So decimals here, 1, 2, 3. So if you fill in, that's going to be 0.007. That is your answer for letter C. Next one, please pause the video and come back and check your answer. So the answer for letter B is 2,780,000, because the decimal was at 2, and then we're moving 1, 2, 3, 4, 5, 6, because the number is going to get bigger because there's a positive exponent. So D is going to be just the opposite. Exponent is negative, so you have to go from the decimal to the small number direction, which is to the left. It's 1, 2, 3, 4, 5. So you should have 4 zeros and 948. And the answer is going to be 0.000092. That concludes today's notes, and thank you so much for watching.